Section 10.1 Parametric Equations. This section we will start with the basic ideas, derivatives, and forming the parametric equations. For the basic ideas, we are familiar with x as an independent variable and y as a dependent variable since y depends on x, or we can see y as a function f of x. This time, we see t. In general, t represents time, so t as the independent variable. X depends on t under the function g of t. Y also depends on t under the function h of t. As you see, x and y both depend on the variable t. And now we have the order pair xy can be related to the same parameter t. Now look at the description or the definition of the equation. The parametric equations have the form x as a function gt, y as a function h of t, and the parameter t varies over the specified over intervals such as t between a and b. It could be from negative infinity to positive infinity, or one end is open. So it depends on what provided in the problem. The parametric curves describe these equations consist of the points in the plane that satisfy the order pair xy, where x is the gt and y is the h of t for t between a and b. The direction of the graph or the direction of the parametric curve is generated as the parameter t increases and is called forward or positive orientation of the curve. Let's look at the examples. For examples 1 to 4, we're going to consider the following parametric equations. Part A, we're going to make a brief table or complete the table of the values of the t, x, and y. So t is provided. We are going to compute the value of x and y corresponding to those the t that given. Part B, we're going to plot all the points. Points mean the order pair x comma y in the table, and make the full parametric curve indicating the positive direction. That means as t increases, what is the behavior of the graph that we obtain? Part C, we're going to eliminate the parameter. That means we're going to get rid of the t to see how x and y related to each other. And part D, we're going to describe the curve as a curve of x and y. Let's get started. The first one, the x is formed by 3 times t plus 2, and y is formed by 12t minus 4, and t is between negative 3 and positive 3. So for t equals negative 3, the x can be found by computing 3 multiplied by negative 3 plus 2, and we obtain negative 7. Similarly, y is obtained by computing 12 multiplied by negative 3 minus 4 to get negative 40. So then we get the order pair as the x and y in the form of negative 7, negative 40. And do similarly for the rest of the t values provided. For x equals negative 2, for t equals negative 2, the x is going to be 3 times negative 2 plus 2 to get the value negative 4. For the y, going to be 12 multiplied by negative 2 minus 4 to get negative 28. And the order pair corresponding to the t equals negative 2 is negative 4, negative 28. And then complete the table with the same way of calculation. For t equals negative 1, we get x equals negative 1, y equals negative 16. For t equals 0, x is 2, y is negative 4. For t equals 1, x is 5, y is 8. And then the rest of them is x equals 8 and y equals 20. For t equals 2, x equals 11, y equals 32. For t equals 3. And then form the order pairs from those values that we just got. For t equals negative 1, the order pair xy would be negative 1, negative 16, 2, negative 4, 5, positive 8, 8, 20, 11, 32. Now we get the table completed, which is part A. Next one, we're going to plot the points from the table and then see the parametric curve and then indicating the positive orientation by looking at the direction as t increases. To get the good graph from the table, the minimum x value or the x min is -7 and x max is 11, where y minimum is -40 and y maximum is 32. To make the graph fit into the provided planes, make sure we include the lowest x, lowest y, the max x and max y. So for the x minimum -7 and x min 11, so we're gonna make the scale. Let's see. So let's make this as the increment of 2 for the x. And then the y gonna be adjusted as increment with the 10 value. Since the y max is 32, so we get 10, 20, 30, and 40. Similar here, -20, -40 here. And then plot the other pairs on this plane. And this is the xy plane. -7, -40 for the first order pair. -4, -28, -1, -16, 2 and -4, 5 and +8, 8, 20, 11, 32. The first one here, when t equals -3, and then the last one, t equals +3. As we see the trajectory or the orientation of the graph going in the direction as t increasing. So we don't include t equals -3 because the boundary of the t or t is strictly greater than -3 but less than 3. So the direction of the parametric curve is going up in this direction. They put the arrow to represent the orientation of the parametric curve as t increases. So we got part B done, plotting and indicating the positive orientation by using the arrow. So over here, t equals +2. So we don't include the two endpoints, so put an open circle at those two ends. And then part C, we're gonna eliminate the parameter, which means the parameter t, to obtain an equation in x and y. As x equals 3 times t plus 2, and y is 12t minus 4, we're gonna rewrite x in terms of y or y in terms of x either way, but t will have to be gone. So there are different ways to do this. So one of the ways is to eliminate the t by rewriting t in terms of either x or y and then substitute into another one. And this one, it looks like it's easier to solve for t using the first one or the x term. So for this one, we get t or 3t equals x minus 2, okay, or t equals x minus 2 divided by 3. And after that, we substitute into the equation of the y to get y equals 12 multiplied by x minus 2 divided by 3, and then minus 4. And simplify it to be 4 multiplied by x minus 2 minus 4. One more time, distribute 4 to both terms in the parentheses to get y equals 4x minus 8 minus 4 becomes minus 12. Now we get the equation y in terms of x, and we are done eliminating the parameter t. When we see this, it looks like we have the equation of the line. So part D, we're going to describe the curve. So we have the parametric graph is the line. Actually, this is the line segment because it's starting from greater than negative 3 and then stop at right before 3. It's the line segment with the equation y equals 4 x minus 12 and m or the slope is 4, and with the direction, so it's the increasing, and the line is increasing from the left to the right. And make it more specific. Since t is between negative 3 and positive 3, for t equals negative 3, the x from the table, x is negative 7, and t equals 3, x is positive 11. So then the bound of the graph as x will be bounded by x greater than negative 7, less than the value 11, and y will be greater than negative 40 and less than 32.